Yes, sir, audible, sir.
Thank you, Dr. Sagre, for introducing me. Good morning to all. Today, we are going to see the industrial revolution from last 2 decades. I'll start my presentation and we'll come to the latest technology which is called as additive manufacturing, which is the key factor of industry 4.0. Give me a second. Is it visible?
Yes, sir. Yes.
Thank you.
It's visible, sir.
I think now it is on the screen. Okay. So we will start with industrial revolution. See, all the dignitaries available here, present here, are from industry or from academia. Uh, we all know the industrial revolution was there, and it starts from the 1784. These are the four revolutions, actually five revolutions. We are in the verge of transformation from 4.0 to 5.0. Actually, before going in future, we should know the past. So we'll brief shortly what happened in the brief past. A period, in the past period, the major technological and socio-economic change started in Great Britain actually. When the industry was not in picture, labors were there and everything which was made by labor by the hands, and slowly it comes to the machines. When it comes to machine, it was the first revolution, that is industrial industrial revolution called as 1.0. Mechanical machines were introduced due to the invention of iron and everything. So from hand labor, it shifted to the machine, and individual machines were there used where we can make the product, and for day-to-day use for weapons or defense, everything was made in machine. Slowly, it comes to the industry 2.0, where only one single machine was not there, but assembly line introduced. That means more complex product can be made with the help of electrical century. After 18th century, when the invention of some PLCs and electronics and IT system was introduced, the automated production was in Industry 3.0. We generally called it Industry 3.0. The programmable logical control, which used the electronics, IT system, automated production was there, and inspection Raj, what we can say, was there. Once the product is made, then inspection department or quality department was in existence. The quality control department was in existence. Total quality control, TQC, TQM, we know all. What was the role of TQC and TQM was actually in industry 3.0 at that time, or even now also in automotive, assembly lines are there, but slowly the progress in computers or the electronics and the programmable logical control, that is CNC, DNC, VMC was used from 1969. So 19th century was the main area or main period when the industry shifted from mass production to smart production. Now this smart production going somewhere in industry 4.0, where AI ML, Internet of Things, robotics, big data and cloud computing can be used in the manufacturing system. At that time in 19th century, we couldn't think that the industry may be so smart that the labor do not have to take the decision, the machine will take the decision, and all the work will be done with the help of the logically controlled machines. So in industry 4.0, wherever we were using the subtractive manufacturing, now it shifted to additive manufacturing. What was this subtractive manufacturing? Everybody knows subtracting manufacturing was the, suppose the lathe or a milling machine or the machines which removes the extra material to give the required shape and size to the product or to the raw material to manufacture or to transfer the workpiece to the finished product or finished good. Here you can have the example of CNCs also or VMCs also or your other machines also where cutting tools were used, and the cutting tools with the help of the smart machines, they remove the material, extra material, and produces the final finished good, which can be further used in assemblies or directly that can be used in your home appliances, your automotive, your defense instruments, your you can say the aerospace, everywhere you can use. But the limitation of that subtractive manufacturing was the complexity was limited. The big complex or a small complex shaped product cannot be manufactured with the subtractive one. So you know now the subtractive, and will go for the additive manufacturing. Before that, what is the future? So we are in the verge of industry 5.0, where the humanoid robots will be used, where the raw material, from the raw material to the finished good, there will be no hand touch. The robots will load everything. The robot will use for all the machining operations, and artificial intelligence will be there. Renewable resources will be there. Bionics will be there, and sustainability will play the great role in industry 5.0. So we have already talked about the industry 4.0. What is the we are living in 4.0 actually. Represents the fourth industrial revolution. Focus on the automation, IoT means Internet of Things, AI, artificial intelligence, big data, and cyber physical systems. Actually, Industry 4.0 aims for intelligent, connected, and self-optimizing manufacturing. This particular 4.0 also integrates the humans, machines, and data across the production processes. Now we will move. What is the role, before moving to the role of additive manufacturing in industry 4.0, we should know what is the additive manufacturing. We already discussed that addition and subtraction. The traditional methods, now also it is being used, the subtractive manufacturing. But what is the additive manufacturing? Additive manufacturing is nothing but a 3D printing, building objects layer by layer. Unlike subtractive manufacturing, it adds material only where needed. And in subtractive manufacturing, we are removing the material which is extra from the raw material. from the workpiece. Here, opposite to the subtractive, we are adding the layers by layers to wherever required. You can see in the picture a metal powder. Actually, the represent we are representing this particular picture I am showing is to get the clear cut idea what is the additive manufacturing. Here the metal powder is seen and steel part can be made. How it can be made? Now we will go in detail. It is actually driven by digital CAD data. Now we are living in a smart world with the n number of tools which can be used to gather the information of the product and can be analyzed and can have the different models. That models can be cut virtually. You can slice them. You can have the different files, str files, and that str files can be given to the smart machines. That smart machine can operate that tool which can maybe array or you can say the heat source, x-rays, everything. That gun will be ordered by the CAD data or the model. This allow the complex and customized product. The material which can be used in additive manufacturing are metals, different types of metals, polymers, ceramics, and composites. Further, we'll move the towards the role of additive manufacturing in Industry 4.0. How it plays the crucial role in 4.0, Industry 4.0. It actually bridges the digital design. What I have already explained, the digital design should be made before proceeding for the manufacturing of any product. You have to make it a digital design. This digital design can be made with the help of the softwares, and intelligent production can be started. This digital design and intelligent production will be breached with a smart system. How we will see in the next slides. It enables on demand, decentralized, and flexible manufacturing. We are well known about the FMS, that is flexible manufacturing, but it can be truly justified by the additive manufacturing. Flexible manufacturing means what? We can change the product, we can use the existing system to manufacture the different products, different designs, different finished good, or different materials can be used. Then again, this additive manufacturing supports the mass customization and product personalization. Again, next forms a key link between digital design and physical abilities. So, role of additive manufacturing is crucial because Industry 4.0 says the smart system should be used, but smart system can be used only when we are using the smart manufacturing process, that is additive manufacturing process. Again, how to integrate or integration with other Industry 4.0 technology. Additive manufacturing is a part, is one area of which is very much crucial area of the Industry 4.0, and it is connected with IoT, AI/ML, big data, cloud computing, and digital twins. So what IoT will do in this particular 4.0? So IoT supports the sensors. That sensors track temperature, quality, and process parameters. So everything which can be used or which is necessary for the manufacturing, that can be tracked with the help of sensor through IoT. Now the second tool of Industry 4.0 is AI/ML, that is artificial intelligence and machine learning. So AI/ML will play the important role to detect the defects, predict the failures, and optimizes all the machining parameters. Next, the big data will again play the crucial role to analyze the process data for continuous improvement. Whatever data is available with the help of this particular tool, we can analyze the process and we can improve the system continuously. Cloud computing will play the important role in stores and to store and shares the 3D models globally. 3D models globally, that means you can create a model which can be stored in your PC or your pen drive or your whatever memory gadgets will be there, or you can send it to the cloud, which you are well known about now. And this particular 3D, your 3D model can be used by the Germans, it can be used by the Japanese, or you can send it to America, where the additive manufacturing process can be started. Of course, the right will be with you. You can charge them whatever you are doing with the 3D models. If your product is there and if they are passing that product, no need to give the physical any prints or anything. You can directly share through cloud computing and they can use your 3D models globally. Digital twins simulate the enhanced printing performance. So these are the other technologies which can be used in use with the additive manufacturing in 4.0, industry 4.0. Next, the digital integration, how the digital integration will be happening. Additive manufacturing relies on 3D digital models integrated into digital manufacturing ecosystem, facilitate the digital twins for simulation and optimization, and it connects the design, production, and supply chain data seamlessly. When we are talking about additive manufacturing, it is not limited to the manufacturing itself only, but the other processes of the industry, the smart industry, that it may include the uh, your design department, your supply chain department, or the research and development R&D department. So it facilitate the digital twins for simulations before manufacturing. For it also facilitate the optimization before manufacturing, and that they such that they can connect efficiently the design, the production, and the supply chain data seamlessly without any hashback. So, when we are talking about the additive manufacturing, we must think about the sustainability aspect. What is the sustainability aspect in AM is we are using uses actually only the required amount of material and minimizing the waste. Here, whatever we have already discussed about the subtractive manufacturing and the additive manufacturing, you can see in the picture A, the material is there, subtractive manufacturing is there, 3D object will be made and the waste will be, you can see. Then in the series B, material is there, additive manufacturing, you can add layer by layer and a very small amount of waste will be there. So the supports, it actually supports the recycling and remanufacturing of the material, reduces the transportation and energy used through local production. So when you are reducing the transportation, you are reducing the handling, the energy required for transportation and in the re-handling of the workpieces or raw materials and the finished good, of course, will be keeping or giving you the carbon footprint. So the carbon footprint also can be reduced with the help of additive manufacturing, and the sustainability will be there for this particular aim. It also contributes the circular economy models for globally, and it is been accepted all over the world that this particular manufacturing will be sustainable and with very minimum carbon footprints in the environment. Also supports the and supports the recycling and remanufacturing of the material. Whatever material is there as a waste, again it can be used, reused. So these are the advantages of additive manufacturing. That is, complex designs are possible without extra cost. Complex design means you can manufacture any type of product with the help of this. There is no limitation now. Before that, for a traditional or for a subtractive manufacturing, there is limitations, which machines can be used, which material can be used, how the tooling will be there, how which tool has to be used. Now it is not like that. Rapid prototyping accelerates the innovation. When you are saying rapid prototyping, it will boost your innovation. You can invent the new products, new shape, new sizes, everything. Material efficiency and sustainability will be there, whatever we have seen in the previous slide. Reduced need for inventory, print parts or on demand. Actually, what demand or what order you will receive, if it is not been fixed by the industry, and if you are vendor and you are using AM in your industry, you need not have to worry the changes or the demand change in from the customer or from your whatever work you are doing. Suppose Tata or Mahindra or any automobile industry is launching a new car, new design will be there, and you are doing your job with this particular industries from last so many years, and now you don't have to fear that the how new design or will be produced in your industry. You can change anytime, and don't worry about the inventory whatever you have to maintain, because it will allow you to reduce your inventory at minimum level. Lightweight and strong structures for high performance can be made by the additive manufacturing. Next, what type of industrial application nowadays uh, can be made with the help of AM? So basically in aerospace, it is most popular one. Lightweight components, fuel efficiency, structures, everything. Nozzles are made, different types of nozzles, different shapes of nozzle can be used in aerospace, and that can be made in AM. Automotive, that is prototypes can be made, custom their limited edition parts can be manufactured with the help of AM. Actually, in the car, what is the wherever the dashboard or the other wheels, your other products used in the interiors of the car are mostly manufactured with the help of AM nowadays. Healthcare, again, it plays the vital role to manufacture implants, prosthetics, surgical models, everything. Construction, again, 3D printed houses and infrastructure already been manufactured in European countries with the help of AM. You can see if you Google, you search in Google, you can have the videos of this particular type of houses and infrastructures in Europe also. Consumer goods, again, personalized fashion, eyewear, and sports gear can be manufactured with the help of AM. These are the industrial applications of AM. Now, if we move further, what are the types of AM process? So there are seven types of AM process for MTech. Those who are completing their MTech in advanced production system or specialization in manufacturing or specialization in production systems have to study this particular thing, that is AM additive manufacturing. They have to look in depth. So material jetting they have to learn. We don't have that much time to go in depth of each and every type of AM, but you should know there are seven types of additive manufacturing process can be choosed, can be utilized for a particular cases. Wet photo polymerization will be there, binder jetting will be there, material extrusion will be there, directed energy deposition will be there, sheet lamination, one by one sheet will be laminated or stick together. Powder bed fusion. This powder bed fusion is the most popular AM process. So what are the challenges and limitations? High equipment material cost. Of course, there will, if smart system has to be used, you have to spend some more money, but it will be one-time investment, and that can justify the flexibility with you for the different products from different orders. Slower for mass production compared to traditional methods. Quality control and repeatability issues may arise. That research is going on still. Limited material availability, because it's material, not every material can be 3D printed. Cyber security and IP production concern. Of course, we have discussed, if you have the 3D model and you want it to sell it to any other country also, they should not use illegally. So cyber security is necessary, because again you are going with the cloud computing and everything. So of course the IP production and these things will be matter. Future of AM. Actually, artificial intelligence driven, AI driven autonomous 3D printing will be there nowadays, or maybe used development of smart and multi material printing will be there. So nowadays, only single material has to be used to produce a single product. It may go to multi material. Hybrid manufacturing combining with the AM with CNC machining, 4D printing, 3D printing we have learned, we have seen, we know everything about 3D printing. But again, for the fourth dimension can be added in future. Maybe you young and dynamic guys work on this, and you can select the area of research for your PhDs or your next qualifications. The 4D printing again a challenging area is there. Structures that changes over time. Global networks for distributed digital manufacturing. These are the future trends. Now we'll come to the conclusion, because this additive manufacturing is the vast topic or a manufacturing process which has to be studied in depth, and 2, 3, 4, 5 hours will not be enough for this particular topic. But my intention with this particular topic to deliver was to get the awareness among the young researchers and young academic coordinators and teachers, that this is the area where you can also focus. Like in our time is still is our time is going on, but whenever we were in 30s and 40s, we were very enthusiastic about the industry for 3.0, the mass production and everything, CNCs, DNCs, programming, PLCs. That time we have studied that. Now it is your turn to go beyond that and what is the possibility in AM should be searched by you people. Additive manufacturing is the key pillar we already discussed, promotes smart, flexible, and sustainable manufacturing, bridges the digital physical divide in production. Before the computers or before these all cyber technologies, only physical industry was there. Future factories will rely heavily on AM for innovation and efficiency. It is the truth. You have to accept. We are, all should accept that the mechanical engineers should be grow or progress with this particular IT sector also. Do not, I'll request everyone to do not promote the only to go for the software engineers and software tester, and software industries is not the only industry which will be growing in future, but the manufacturing industry 100% have the good future for that, but we have to learn all these technologies also. Without it, the mechanical engineers we means can't be survived. Some videos are there before starting question answer. We can see it so that you can have the clear cut idea about what we have learn today. Suppose a jet manufacturing. This is the aerospace jet used in aerospace. Just have the look.
Mic on, Salim. Sir, video is not visible to us.
Video is not.
Still not, sir.
Now,
What is additive manufacturing?
No, sir.
it is not visible.
Manufacturing, also known as 3D printing,
Just a
is a process that creates a physical object from a digital.
But you can hear their sound.
Yes, sir.
What they,
Voice is audible to us.
Yes, yes.
now,
What is additive
No,
manufacturing?
sir.
Additive
is it visible now?
No, sir. PPT is visible. Video is not visible to us.
Okay.
Yes, sir. Visible, sir. Please
Okay.
say it.
Yes, sir. Visible.
manufacturing, also known as 3D printing, is a process that creates a physical object from a digital design. An engineer designs the object using computer-aided design or CAD software. The 3D design file is then sliced into thin layers and uploaded to an additive manufacturing machine. The manufacturing process begins once an extremely thin layer of metal powder is spread across the platform. A heat source, such as laser or electron beam, then melts the first layer of the 3D design. The platform is lowered, and another layer of metal powder is spread across the platform. The layering and melting process is then repeated until the part is complete. The metallic powder is removed, and a physical object is revealed. Additive manufacturing allows you to produce parts that are lighter, stronger, and more durable than traditionally made parts. Build times are faster. Engineers can add precise features and complex geometries without increasing cost. In fact, additive manufacturing is revolutionizing the way we work. Is revealed. Additive. The manufacturing process begins once an extremely thin.
Here, whatever the data is fed to this particular machine, is the files which called as STR file, stereolithography file. When you will go in depth in the manufacturing processes with the type, so stereolithography will be the word which you are using again and again for designing or for modeling it. Once the model is ready, we have to cut that particular model in slice. One slice may be in microns. Suppose the 50 microns or 100 microns or 200 microns will be the thickness of that particular slice, and this will be saved as str file and will be sequentially feeded to the machine through the computer.
One layer of metal powder is spread across the platform. A heat source, such as laser or electron beam, then melts the first layer of the 3D design.
This first layer will completed after the str file is finished. Then second str file will be feeded and it will go on. Can you understand now? Can you understood now? Am I audible to all?
Yes, sir, you are audible.
So we'll go for the next video. This is a nozzle. Made with the help of additive manufacturing. Okay. Any questions?
Dear participants, if you have any query or doubt, you may ask to Dr. Mansuri sir, or you may type in chat boxes, so that we will take up during this session. Sir, one question in chat box from Radha Krishna Singh.
Apart PVC, any other material can be used. 100% other materials are used. Polymers are, of course, there. But nowadays, special type of steel is being used. That is called H112 steel, which before using the powder will be there. The powder size, the grain size will decide the finishing of the final product. So ceramics will be there, then plastics will be there. Of course, PVC is the simple material, but after PVC, we have to use the special type of metals. Metals will be there, but that metal will be a special metals, which can be sensitive to the laser or a heat source, whichever you are using in the machines.
Any other participants?
These are additive manufacturing is the most important thing which is used in manufacturing of the defense its instruments or the healthcare instruments also. Okay, Dr. Sagre.
Yes, sir. I think no participants
Okay,
have any question or
I have given you the details of whatever your demand was there. 10 questions.
yes, sir. Yes, sir. We will share on WhatsApp group after this session.
Okay, sir. If anything more, individual candidate can contact me personally.
Yes,
Thank you.
sir. With your permission, shall I conclude this session now? I think no participants have any question or doubt. Uh, I I think our participants little bit shy, so
Okay,
they
no
don't
problem.
ask the questions.
Once a while we were like them only.
Yes, sir. So, with your permission, I am concluding this session.
Okay.
Thank you very much, Dr. Arif Mansuri sir, for such an insightful and enriching session on role of additive manufacturing in Industry 4.0. Your detailed discussion on the application, challenges, and future potential of additive manufacturing has truly broadened our understanding of this vital pillar of Industry 4.0. On behalf of Mahavir Polytechnic Nashik and all the participants, I sincerely thank you, sir, for sharing your valuable time, knowledge, and experiences with us. I also thank all the participants for their active involvement and attention throughout this session. Please don't forget to fill the feedback form and complete the assignment, which will be shared on WhatsApp group. Uh, we will now take a short break and rejoin for next session as per the schedule, that is at 1 p.m. Next session will be started at 1 p.m. So thank you once again, sir, for your wonderful contribution to this FDP.
Thank you, sir.